This is a code for creating a Pascal's triangle. It is divided into three parts: the algorithm for making the triangle, the loops for painting the triangle like a pyramid, and the lines for getting the number of rows from a user. The other two is less important than the algorithm, so let's focus there. On the function definition, there's an int parameter called numRows. And for this example, I will be using a value of 5 for numRows. On the next line, there's a placeholder list called triangle. This triangle will contain all the other sublists that will make up the whole Pascal's triangle. Let us proceed into making that Pascal's triangle. In loop 0, since I is 0, a list of 1 will be created. This list of 1 will then be added to the placeholder list named triangle. In loop number 1, since it is no longer 0, and from this point onwards, it will always fall on the else block. Here, a list of 1 will also be created. Then it will create a variable selecting the previous row, and based on the number of items in that row, it will run a certain line of code. In this case, since there's only a single item in the previous row, then that line of code will not run. The line of code will make more sense later in the video, but for now let us just add a closing one, then add the row to the triangle. Next loop, it will also fall on the else block. Create a 1, then select the previous row. This time, the previous row has two elements, so the subloop will run for one time. And what the line of code here does is that it adds a pair of preceding numbers from the previous row. Like in this case, 1 plus 1 is equal to 2. That is then added to the row. Then as usual, a closing one will be added before adding this row to the triangle. This will go on and on until a sufficient number of rows is met. Now that the Pascal's triangle is completed, let us look at the analysis for this algorithm. For the running time, there are two nested loops that can be noticed in this algorithm. This code is similar to this code snippet in the C# language. For this special case of nested for loops, creating a table is necessary for understanding its running time. When I is 0, j is also 0, hence j will not run at all. When I is 1, then j will still not run, since when j, which starts at 1, is still not less than I. However, when I is 2, then j will run one time, when j is just 1. After that, when I is 3, then j will run two times, when it is 1 and 2, since those are still less than I, which is 3. But it will stop when j becomes 3, which makes it equal to I. Looking at the table, you should notice that there is a pattern. If I is n, then j will run for n minus 1 times. And from this observation, the running time is like 1 plus 2 plus 3 until it reaches n, which could be summarized by the formula for the sum of natural numbers, n times n plus 1 all over 2. Multiplying, it becomes n squared plus n all over 2, which would make the overall running time of n squared. The space requirement is similar to the time complexity, because as you can see in the first row, there is one element in the list. In the second row, there are two elements. Then in the third row, there are three elements, and so on. This is also like 1 plus 2 plus 3 and so on, which would be simplified again by n times n plus 1 all over 2, which would become n squared plus n all over 2. Therefore, the space requirement will be O of n squared. For the input size, as you can see, there's only one parameter in the function definition called num_rows, which is just a normal variable that has a type of integer, hence its input size is just O of 1. That is all. Thank you.